This is part 2 of the walkthrough of the AQA GCSE Combined Science Physics 2023 Higher Tier Paper 1. Question 5. Figure 10 shows a child's toy. A child pushes down on the toy to compress the spring. The spring then launches the toy into the air. 5.1. A student measured the maximum height reached by the toy. The student placed a vertical meter rule near the toy and observed the height reached by the toy. The student repeated the experiment, observing from a different position. Figure 11 shows the toy at its maximum height and the two positions of the student. So we can see that in position A, the person's head is below the object, specifically the eyes. And you can see in position B that their eyes are in line with the toy. Observing the toy from position B instead of position A affected the measurement of the maximum height reached by the toy. Explain how. Well, what the difference in their position is known as, it's known as a parallax error. And this is due to the eyes being below the object and not in line with it, as we were just describing. So what that will mean now is that the measurement will be different, and most likely it'd be higher in A. But for them in B, it should be closer to what it should be. So obviously that means that it's more accurate. So the idea that we should be including here is that the measurement will be more accurate from position B. And we've given the explanation for that, as the eye is in line with the toy. (5.2) The greatest height reached by the toy was 64 centimeters. The gravitational potential energy of the toy at this height was 0.049 joules. Gravitational field strength is 9.8 newtons per kilogram. Calculate the mass of the toy. Use the physics equation sheet. Give your answer to two significant figures. 5 marks. So we've got to decide which equation do we need to be using here from our sheet. Well, remember that we have got the height, gravitational potential energy, and we've got gravitational field strength. So what equation involves those factors? It's going to be gravitational potential energy equals mass times gravitational field strength multiplied by height. So let's put in our values now. The height was 64 centimeters. Just like in the previous part, we have been converting units. So this time we need to convert from centimeters to meters. So to do that, we need to divide by 100. So that means our height is going to be 0.64 meters. We need to multiply that by 9.8, which is our gravitational field strength. But the gravitational potential energy was 0.049 joules. So we're given the energy, so that means we need to rearrange to find the mass. So let's rearrange our equation now. So it'll be 0.049 divided by 9.8 multiplied by 0.64 will equal our mass. So if we do that in a calculator, we'll come up with a value of 0.00781. But it is asking us to give our answer to two significant figures. So remember, we're including the zeros up until we get to two numbers that are not zero. So that will be 0.0078 kilograms for our answer. (5.3) When the spring launches the toy into the air, the temperature of the air increases. Explain why the child's toy on its own is not a closed system. So what does it mean by closed system? This means that energy is not going to be transferred to the surroundings. It's going to remain in that system, just be transferred. So this says the temperature of the air is increasing. So that indicates to us then that energy is being transferred to the surroundings and away from the system, which is the toy in this case. So there's our explanation. Our explanation to why it's not a closed system is because energy is being transferred to the surroundings. We wouldn't expect that in a closed system, so we'd expect the total energy that is in that system to remain the same. Question 6. Figure 12 shows a device that uses a mug of hot coffee to turn a wheel. 6.1. The hot coffee increases the temperature of the air in the chamber. Explain how the pressure in the chamber changes. So, we've got hot coffee. If it's hot, that means that there's going to be particles that are going to be moving. And we would expect steam to be released from our coffee. What that would then do is it would cause the chamber to start increasing in its temperature, and then that will cause the piston to move, which will cause the wheel to start rotating. So the particles moving is the reason why there's pressure that's going to be changing. Because remember that pressure is due to force in a certain area. So the force that is occurring is due to there being collisions between particles and between a container. So every time that there's a greater collision, there'll be more force. So let's just focus before we try and answer our question now on the question again, explain how the pressure in the chamber changes. Well, changes could be an increase or decrease. So what we want to do is you want to state whether it's going to increase or decrease. The temperature is increasing. If there's an increase in temperature, there'll be an increase in pressure. So you can start by just stating that the pressure increases. And now we can get on to our explanation. Now, why is the pressure increasing? Remember, it's to do with the particles moving faster. Remember, if they're moving faster, that means that they have increased kinetic energy. And then what happens when these particles move faster? This causes greater collisions to occur in a certain period of time. 6.2. For the device to work, the air in the chamber must increase in temperature quickly. Explain why the bottom of the air chamber is made of metal rather than plastic. So, increasing temperature quickly, we want this chamber to do. So if we want there to be an increase in temperature quickly, then that means, if we go back to our diagram now, that means that if there's an increase in temperature in this location of our chamber, then we want that to pass to the next part, and the next part, and the next part, and so on, and so on, and so on. So that movement of that thermal energy, because remember temperature is thermal energy, that's going to be called thermal conductivity. So thermal conductivity depends on the type of material that the object is made from. And in this question, they've given us two materials, metal and plastic. So we would expect the metal to have a greater thermal conductivity than the plastic. That's why you use metal pans when you're cooking instead of plastic pans. So what can we say about the thermal conductivity? It's going to be higher for the metal. So the further explanation for that then is that the rate, because remember it's about quickness now, the rate of this thermal energy transfer is going to be greater. Six point three. The mass of the air in the chamber is constant. What property of air allows a small change in internal energy to cause a large temperature change to the air in the chamber? So what property of air will cause a large temperature change? They've put this sentence on its own. The mass of the chamber is constant. So we're thinking about a property of air that's linked to mass and temperature. Well, let's think about energy. What can cause a change in energy linked to mass? Well, that's called specific heat capacity. Let's recall the equation to help us. Equation for specific heat capacity is energy equals mass multiplied by specific heat capacity multiplied by temperature change. So if we've got a greater temperature change, we should have greater change in energy. Remember, the mass stays the same. Every material has its own specific heat capacity. So the specific heat capacity is lower, you'd expect then to be a smaller temperature change. So that's what the property is. It's the specific heat capacity. Six point four. The changes in pressure in the air chamber cause the wheel to turn. Suggest one way to increase the speed at which the wheel turns. So we've just been discussing earlier that the temperature increase due to this hot coffee, and then that will cause the pressure to change. So the question is saying, how else could we cause the wheel to turn? Well, we've been discussing temperature, and we said that the temperature could cause an increase in pressure. So if we use a hotter coffee, so increase the temperature of it, that should cause there to be a faster turn of the wheel. What else could we say then, other than this? Well, going back to the wheel now, remember that for the wheel to turn, there needs to be some movement of something that's attached to the wheel, just like a wheel on a tire in a car or a bicycle. And that means that there are moving parts in the wheel. Now, what could be the problem with those moving parts? They will be rubbing against each other, and that rubbing against each other is called friction. And every time that there's friction, it causes heat. Then it could also cause there to be slowing down of the wheel as a result. So, to avoid the wheel slowing down when it's not supposed to, we could lubricate the moving parts, for example, adding some oil. So another option could be adding lubricant to the wheel or oil, for example. 6.5. The temperature of the coffee decreases as the device is used. The initial temperature of the coffee was 76 degrees Celsius. The internal energy of the coffee decreased by 15 kilojoules. The density of the coffee is 1.1 times 10 to the power 3 kilograms per meter cubed. The volume of the coffee is 1.9 times 10 to the power minus 4 meter cubed. The specific heat capacity of coffee is 4,200 joules per kilogram degrees Celsius. Calculate the final temperature of the coffee. Use the physics equation sheet. 6 marks. So we're given many values here. So this is telling us that we have to use multiple equations. So this is a compound equation question. So we've got temperature, 76. We've got internal energy, 15 kilojoules. A density value, a volume value, a specific heat capacity value. So one equation that we probably will need to use will be that equation that we just recalled earlier. Energy equals mass times specific heat capacity multiplied by temperature change. Let's just check to see what we have from this equation first. We have some energy. We don't have a mass. We have specific heat capacity. And we have an initial temperature. And we're trying to find the final temperature. So that would indicate that we would need to use this equation at some point. But we can't use it now because we don't have a mass. And because we don't have the final temperature, we need to find it. We definitely can't use it right now. So what haven't we identified to use in this equation? The density and the volume. So what equation can we use that involves both of those? Well, that would be density is equal to mass divided by volume. So what might make sense first then would be to use this density equation and then rearrange it to find the mass, and then put our mass into this second equation for specific heat capacity, and then rearrange that to find the temperature change. So let's do that first. Let's rearrange the equation. We'll plug it in first and guarantee ourselves a mark. Density is 1.1 times 10 to the power 3 equal to the mass we don't know divided by 1.9 times 10 to the minus 4. So rearranging that now, mass will be equal to 1.1 times 10 to the power 3 multiplied by 1.9 times 10 to the power minus 4. So putting that into our calculator, we'll get an answer of 0.209 kilograms. And then we can put that into our equation now. So let's just state the equation again and put the numbers underneath it. So energy was 15 kilojoules. So let's convert that to joules. So that'll be 15,000 joules. Our mass we know now 0.209. Specific heat capacity is 4,200. Remember, we don't know the temperature change. So we're rearranging this equation now. So 15,000 divided by 0.209 multiplied by 4,200 equals the temperature change. So putting that into our calculator now, we'll get a temperature change value of 17.088. Continuing, but to make it easy, we're going to just use 17. So putting that to two significant figures. So our temperature change right now is 17 degrees C. It said though that our initial temperature was 76 degrees Celsius. It says that the temperature of the coffee decreases as the device is used. So if the temperature change is 17 and the initial temperature was 76 and it's going to decrease, what we would need to do then to find the final temperature is do 76 minus 17, and that will give us a final answer, a final temperature of 59 degrees Celsius.